Hello everyone, this is Jessica here. A very warm welcome to today's webinar. What if I could show you a way to make your building's HVAC system not just smarter, but truly manage itself? Over the next while, we'll unpack exactly that. Our smart, autonomous, unified HVAC control system, and how it achieves one critical outcome, saving energy, time, and money automatically. So before we begin, let me quickly outline our agenda for today. We'll start with an overview of the HVAC control market. Then, we'll introduce the new opportunity with Milesight, looking at our solution components and system topology. The core of our session will walk you through the three pillars to build a smart HVAC system: smart control, autonomous operation, and unified management. Finally, we'll share some real-world success stories from different regions. The entire presentation will last about an hour. Please feel free to type your questions into the Q&A box at any time during the webinar. I'll address them all at the end. With that said, let's jump right into our first section. Challenges existing in the HVAC control systems. Exploring the global thermostat market has been eye-opening, and the US market is a perfect example of its huge potential. The data shows the top three HVAC systems here are rooftop units, heat pumps, and PTACs. And they're used everywhere, from commercial buildings to hotels. This gives us much confidence to promote the WT series locally. We've also seen massive growth in smart thermostats. By the end of 2021, nearly 20 million were installed in US, and that number is expected to almost double by 2026. But here's the key insight. Most of that growth has been in residential. Commercial adoption is still lagging behind. And that's where we see a major opportunity. Look at New York. While over half of businesses use programmable thermostats, very few, only 8%, have advanced controls like smart thermostats or full energy management systems. So, the situation is clear. Most commercial buildings are still running on outdated, disconnected control systems. And many of the so-called smart thermostats are just Wi-Fi models designed for homes, not for reliable, long-range communication in large buildings. Our goal isn't just to replace thermostats. It's to bring real, scalable intelligence to commercial HVAC control system. And the payoff is clear. According to industry studies, smart thermostats alone can deliver up to 10% in energy savings. That's the opportunity we're focused on. Of course, it's not that simple. Commercial HVAC is complex, and choosing the right solution is rarely straightforward. These are a few difficulties that owners of commercial buildings encounter with HVAC systems. Not smart. In order to respond to tenant comfort feedback, building managers frequently tweak HVAC systems based on trial and error adjustments. Traditional thermostats control a room's temperature to a predetermined level. However, they disregard elements like ventilation, sunlight, humidity, and a person's degree of activity. Residents cannot just change the thermostat in large buildings on their own. And final outcome is obvious: the inhabitants' discomfort and pushing energy savings to the back burner. Not autonomous. The system lacks self-optimization and predictive maintenance capabilities, requiring manual intervention to address issues such as component failures, the clogged air filters forcing the HVAC to overwork, inefficient operational habits like unnecessary continuous runtime, and energy wastage from undetected faults like duct leaks or improper power consumption. This reliance on human oversight leads to increased energy consumption and operational costs. Not unified. There's still many commercial HVAC setups or closed systems, which makes it tough to add new devices or support new protocols. But the real impact is on your operations. You get locked into expensive vendor service contracts, and crucial data remains trapped in silos, unable to be used for smarter energy management or predictive maintenance across your building. Now, while IoT is the clear solution to modernize HVAC, there's a real-world problem. A major gap exists between the world of HVAC and the world of IoT. It's like hardwired legacy meets wireless intelligence, and system integrators are stuck in the middle. You see, these are two different worlds. Traditional HVAC relies on hardwired protocols like Modbus or BACnet, with complex wiring and centralized control. It's not built for the cloud. On the other side, IoT devices are wireless and flexible, but they often can't actually control the HVAC equipment. Sensor data comes in, but it doesn't translate into action. To make things worse, integration usually requires extra gateways and converters, which adds cost, complexity, and potential points of failure. That's why at Milesight we're focused on bridging this gap with products designed specifically for this challenge, like our WT thermostats, UC700 controllers, and the EG71 gateway, to make integration seamless, not a struggle. HVAC system integrators and control contractors, we fully understand that you are constantly seeking advanced solutions that can streamline workflow and offer added value to building owners. In a competitive market, selecting the right HVAC control solution is essential. Milesight is advancing HVAC control management for commercial, retail, and school buildings through its innovative solution built on three pillars: smart control, autonomous operation, and unified management. First, smart control uses our thermostats, controllers, and sensors to move beyond simple temperature setting. It delivers intelligence through several key modes. Single unit control for adjusting individual rooms like a patient room or private office. Multi-unit and zoning control to manage entire zones or groups of radiators from one point, ensuring consistent comfort. Occupancy-based control, where the system uses sensors to automatically adjust settings based on real-time presence, saving energy in empty spaces. In short, it's about automating comfort based on actual use, not just a fixed schedule. Next, autonomous operation means the system monitors its own health, tracking things like electrical current and temperature to alert you to issues before they turn into expensive repairs. And finally, unified management brings everything together into one simple platform, giving you full visibility and control from a single dashboard. This chart shows the complete product ecosystem for a smart HVAC control system. From field devices all the way to cloud management, Milesight provides every layer, starting at the device level. Diverse IoT sensors spread all around the building. They work like eyes and ears of the system, measuring temperature, humidity, and occupancy, water leaks, and power consumption, providing real-time data to adjust system performance. Next, thermostats and HVAC controllers act as the hands of the system. They regulate fans, adjust heating and cooling units based on sensor data and commands, supporting everything from legacy setups to modern multi-zone and heat pump systems. With them, you can assure that your building is only heated or cooled when necessary. Then the IoT gateway server as the legs, reliably moving data between your devices and the cloud via multiple backhaul options. And at the top, the management platform acts as the brain. It turns raw data into clear dashboards and insights, giving you full visibility and control. Milesight offer you easygoing and low-code software for seamless integration. Together, these layers deliver a streamlined solution that's quick to set up, efficient to run, and easy to manage, helping you optimize comfort while cutting operational costs. This diagram illustrates the complete architecture of our smart HVAC control system, showing how each component connects, whether via wired or wireless links, and the communication protocols used, such as LoRaWAN, Milesight D2D, BACnet IP, and Modbus. It's designed for seamless integration, all the way from the cloud down to individual devices. One important note: the WT401 does not support the D2D protocol. Meanwhile, the upcoming new model EG71 gateway not only supports BACnet IP and Modbus, but also adds support for more protocols to enable seamless integration of both wired and wireless devices. We'll explore more details about the new gateway later. The how of building a smart HVAC system architecture relies on three key pillars. For the first pillar, smart control, I'd like to focus on the smart thermostat series and the upcoming HVAC controllers. Smart thermostats have made a big impact on the residential market, but haven't really crossed over into the commercial sector. That changed with the introduction of the Milesight WT series smart thermostat that works in tandem with our other sensors for a complete monitoring solution. Milesight WT series offers a full line of thermostats designed for diverse HVAC systems across different regions. From radiator valves in Europe, to PTACs and heat pumps in North America, to fan coil units in the Middle East, and split ACs in Asia and Brazil, we have purpose-built models to match every scenario. Whether wired or wireless, our solutions deliver easy installation, reliable performance, and modern functionality without compromise. Since we already gave a detailed introduction of WT401 in last month's webinar, today we'll just do a quick recap of its key features. Building on the success of our WT thermostat series, the WT401 stands out with its wireless design, eliminating the need for rewiring and enabling flexible installation. It features a 2.7-inch e-ink display, built-in temperature, humidity, and motion sensors, and smart functions like open window detection, freeze protection, and flexible scheduling. It supports multiple communication methods, including Bluetooth, Power Bus, and LoRaWAN. It also offers versatile power options such as USB Type-C, 24 volts AC, Power Bus, or long-term battery operation. The quoted 3-year battery life is calculated based on LoRaWAN communication using SF7, a 10-minute reporting interval, 1-minute data collection, and with the e-ink screen enabled. A key feature is its ability to communicate with radiator valves via LoRaWAN for centralized heating control. Regarding availability, an initial version supporting only LoRaWAN communication will be released in October. Support for Bluetooth and Power Bus will be added in a subsequent firmware update, timed with the launch of the UC700 HVAC controllers in next year. In short, the WT401 delivers a sleek, flexible, and truly wireless HVAC control experience. The WT101 and 102 are our LoRaWAN-based smart radiator thermostats. Both models provide intelligent heating control by precisely monitoring room temperature, but they're designed as coexisting models with distinct positioning. I'll list their shared features first, and then focus on what makes the WT102 unique, which will show you why we offer these two different options. The biggest difference is power. Unlike the battery-dependent WT101, the WT102 is fully self-powered. It has a built-in thermoelectric generator that creates energy from the temperature difference between the ambient and the radiator. So, whenever the radiator is on, it's generating power. Here's the best part. This energy is stored in an internal capacitor. This smart power management allows for 2 operational modes in different seasons. In the heating season, it runs in power-efficient Class B mode, reporting every 10 minutes and responding to commands in seconds. In the non-heating season, it automatically switches to ultra-low power Class A mode, reporting just once every 24 hours. This efficiency allows it to last about 7 months on a full charge once the heating is off. If the capacitor ever gets fully depleted, you can easily recharge it. Just 30 minutes of charging via the USB Type-C port will power it on, and a full charge takes about 5 to 6 hours. Another key feature of the WT102 is the support for an external NTC temperature sensor. Since these devices are mounted on hot radiators, the built-in sensor can sometimes be influenced by that heat. But the external sensor lets you get a much more accurate reading of the actual room temperature, which leads to smarter, more efficient control of the hot water flow. Finally, let's talk about ending the heating season early. You have a few options. You can press the power button on the device to shut it down completely, and of course, you'll need to turn it back on manually next season. Or you can send a shutdown command remotely from the platform. Or simply adjust the heating season dates in the platform, and the device will automatically switch to its energy-saving non-heating mode. If you take no action, the device will stay in heating mode year-round, which will, of course, use more power and drain the capacitor faster. In large spaces like open-plan offices or university dormitories with multiple radiators, walking around to adjust each thermostat manually is just not efficient. What you need is centralized control to make quick, synchronized adjustments across all units. This saves time, ensures consistent comfort, and improves operational efficiency. To achieve this, we offer two flexible control options. The first option is pairing the radiator thermostats with the WT401 wireless panel. Here's how it works. The WT401 acts as a local command point. You adjust the temperature on it, and that command gets sent up to the gateway, which then relays it down to the specific thermostats on the radiators. Now, here's the key difference in performance. When controlling a WT101, that command can take up to 10 minutes to be received and executed. But when controlling a WT102, the response is near instant, as fast as 4 seconds. And this response time is configurable to fit your needs. This setup is perfect for two main scenarios. Imagine a patient room. You can have the WT101 or 102 on the radiator in the corner, and the WT401 mounted right by the entrance. This allows staff to make quick temperature adjustments as soon as they enter the room. For multi-unit control, you can imagine you're in a lobby or a large workstation with many radiators. A single wireless panel can control multiple radiator thermostats. This ensures a consistent temperature across the entire zone without needing to touch every single unit. The second option is to pair the radiator thermostats directly with a LoRaWAN gateway for group control. Now, here's an important technical point. This group management via multicast is only supported by the WT102, as the WT101 operates in Class A mode only. This capability of group control enables two powerful scenarios. A facility manager can set one unified target temperature, for example, 22 degrees Celsius for an entire dormitory building with just a few clicks from his desk. And you can get even smarter for zoned group control. The manager can create different groups for different needs. Rooms that are in use can be set to a comfortable 22 degrees Celsius, while unused rooms are grouped separately at an energy-saving 10 degrees Celsius. This is the perfect balance of comfort and efficiency. Let me break down our UC700 series. They act as actuators that bring true centralized intelligence to HVAC systems. First up, the UC711. It's designed for PTACs, heat pumps specially. You get full control via the WT401 thermostat, with support for 2 heating and 1 cooling stages, flexible 4 fan speeds, including auto, high, medium, and low, as well as scheduling that adapts automatically to time zones. The built-in real-time clock even keeps accurate time for 72 hours during power loss. Plus, it works with door sensors or keycard readers, perfect for hotel retrofits. You can configure up to 8 custom schedules, with each schedule supporting 16 time slots. The USB port can be used to connect an optional NTC sensor for temperature monitoring, which helps prevent wire overheating during operation and reduces fire risk. Then there's the UC701, which solves a big pain point, bringing smart control to standard split air conditioners that come with IR remotes. It learns any IR remote, so you can automate legacy units without replacing them. Ideal for hotels or offices, it supports thousands of split AC models and even tracks real-time energy use. Power it via 5 volts DC or up to 2 years battery, and enjoy features like filter alerts or open window detection. Regarding availability, we plan to officially release them in the first quarter of 2026. Let's take a closer look at their usages and features. In the US, bedrooms, guest rooms, and offices often swing from too hot to too cold because one big HVAC system tries to please everyone. A hotel survey found 3 out of 4 guests adjust the thermostat within just 10 minutes of checking in. All that tweaking wastes energy and shortens equipment life. It's not just hotels. Parents with basement game rooms and students in dorms face the same issues: stale air, noisy units, and high utility bills. Old package terminal air conditioner units can now be upgraded with a UC711 controller and a WT401 smart thermostat, giving each room its own intelligence. As we all know, PTAC is a self-contained heater and cooler that slides through an exterior wall. Once connected to your building network, you can change temperature with a smart thermostat on the wall or BMS platform in remote. Besides that, using its built-in occupancy, temperature, and humidity sensors, the WT401 detects motion. When it determines a room is empty, it enables temperature drift and directly communicates this state to the UC711 controller through Bluetooth or power bus. If connect a keycard reader or door sensor to the UC711's digital input port, the system trims compressor cycles when the room is unoccupied and resumes comfort when someone returns. How smart settings cut energy bills? Energy waste often comes from units running at full power in empty rooms. Our smart PTAC solution fight that waste in 3 ways. First, smart scheduling. Temperature automatically adjusts based on real-life patterns, like relaxing settings during work hours or overnight. Second, occupancy automation. Heating or cooling pauses shortly after a room is empty and restarts as soon as motion is detected. Third, real-time visibility. Track kilowatt-hour usage in real time on the BMS cloud, turning energy data into something easy to understand and act on. And the benefits are obvious. Hotels using sensor-driven PTACs report saving 10 to 35% on annual HVAC costs. For a guest room rented 250 nights a year, those savings typically pay back the upgrade in 12 to 24 months. Beyond energy, maintenance alerts help prevent costly issues like coil freeze-ups or compressor failures, repairs that can top $500 each. Facility managers also save time. Remote diagnostics mean technicians arrive with the right part the first time. When we talk about the smart thermostat opportunity, the biggest battlefield is definitely split air conditioners, also known as ductless mini-splits. These units are everywhere: homes, apartments, small shops, even schools and offices, especially across Asian countries, Australia, and Brazil. That means there's already a massive installed base, and that's exactly where the biggest smart upgrade potential lies. Now, a split AC system is pretty simple. It has an indoor unit and an outdoor unit. But here's the catch. Most of them are still controlled by old-school infrared remotes. That's why retrofitting them with smart solutions usually comes down to 2 approaches: infrared emitters or direct wiring. Infrared has some big advantages. It's broadly compatible, works with nearly every brand, and requires 0 electrical work. Our Milesight solution with WT401 and UC701 combination is built specifically for this. As we know, the main drawback of infrared control is its one-way communication. A smart thermostat can't actually confirm the AC's operating status. For example, if someone turns the unit off with the physical remote, the cloud may still show it as running. That's where the UC701 makes a difference. With current monitoring, it can mirror the AC's real-time status. On top of that, the UC701 uses an external NTC sensor to provide accurate room temperature readings and a current transformer to estimate energy usage. This way, you're not limited to relying only on the thermostat's built-in temperature and humidity sensor. Put it all together, and you've got a solution that's cost-effective, easy to deploy at scale, and precise enough for high-volume residential or small offices projects where both functionality and affordability matter. Now, let's look at two of our well-established products that have already gained strong market recognition, the WT201 and the WT30X series. To give you a clear picture, here I listed exactly which wire terminals, valves, and fans they're designed to work with. First, the WT201. In simple terms, it can directly replace most existing programmable thermostats that control equipment like rooftop units without economizers, PTACs, heat pumps, boilers, and furnaces. The replacement process is straightforward. If your current thermostat runs on 24 volts AC power and has terminals like RC for cooling, RH for heating, and C for common, and the wiring matches the WT201's terminals, then it's a compatible swap. A great example is a hotel project in Argentina, which successfully upgraded their system using WT201 with their existing rooftop unit without economizer. Next, we have the WT30X series. These models are designed to replace programmable thermostats for fan coil units. The key requirement here is that your existing thermostat must support 110 to 250 volts AC input, meaning it's powered directly by line and neutral wires. Now, choosing between a WT303 and 304 model depends on a combination of factors in your specific system. Is it a 2-pipe or 4-pipe system? Does it use a 2-wire or 3-wire on-off motorized valve or a 0 to 10 volts modulating valve? What type of fan is it? A 1 to 3 speed fan or an ECM electronically commutated fan? To make this selection process easier, we have an online tool to help you quickly determine if our WT models are compatible with your HVAC system. If the tool isn't enough, you can always take a photo of your current wiring and send it to our technical team for confirmation. Now, some of our longtime users who know the WT201 might have a question. If both solutions can control PTACs, heat pumps, and boilers, and the WT201 is already affordable and well-equipped, why did we even develop the WT401 plus UC711 combo? The answer really comes down to one thing: installation flexibility. Think of the WT201 as an all-in-one solution. It has the control logic and wiring terminals built directly into the thermostat itself. It's perfect for standard setups, especially in new constructions where the HVAC wiring is already in the wall. It's cost-effective. It has physical buttons and an LCD screen, so it's a straightforward and reliable choice. The combo WT401 plus UC711, on the other hand, is a modular system. This is a game changer for retrofit projects where running new thermostat wires is too expensive, too difficult, or just impossible. The WT401 thermostat talks to the UC711 controller wirelessly via Bluetooth or over a simple power bus cable. This eliminates the need for complex rewiring. The thermostat has a crisp e-ink screen with customizable display content, and all the configuration for the controller is done remotely via an app or our cloud platform. There are no physical buttons on the controller itself. So, in short, the WT201 is your go-to for standard installations, while the combo is purpose-built for flexibility in retrofits and complex projects, making installation much simpler. To wrap up our look at the WT family, here's a side-by-side comparison. This chart includes our existing products and what's coming soon, comparing their capabilities across the board. It's a great resource for planning. I encourage you to save this slide for your own review later. Now that we've covered the first pillar, smart thermostat control, let's move into the second one: autonomous operation. Managers of hotels, commercial properties, foreclosed properties, offices, or any other building have all experienced problems with their HVAC, heating, and/or boiler systems. If there is anything irregular with the temperature, electrical current, and/or humidity around your machinery, they run a higher risk of costly failure. Keeping buildings comfortable pushes HVAC and boiler systems hard, and we often take them for granted until they fail. When they do, the costs add up fast. Repairs average $500 to $600 per incident, and full replacements can run up to $50,000. This reactive mindset, however, leads directly to the costly breakdowns described above. Data shows that a significant majority, 66% of New York businesses, wait for equipment to fail before servicing it. Only about a third employ preventative maintenance, leaving systems vulnerable and customers facing unexpected repair bills. This gap between recommended care and common practice is precisely what new IoT technologies aim to solve. With Milesight's wireless sensors, you can track temperature, humidity, electrical current, and even water leaks in real time, from anywhere. Instead of waiting for a breakdown, you get an alert at the first sign of irregular operation, so you can act before small issues become major repairs. Take this boiler as an example. Boilers must maintain a certain temperature, humidity, and electrical current level for safe, reliable, and effective operation. That's where LoRaWAN-based smart sensors come in. In this setup, we can place the temperature sensors on the pipeline surfaces or inside the duct. Perfect for monitoring heating systems, the TS302 includes two high-precision PT100 temperature probes. You can easily attach them to radiator flow and return pipes using plate or clamp accessories, while the main unit mounts neatly on a wall or magnetically onto the boiler pump. It's designed for real-world conditions. The probe length is customizable. Temperature range stretches from -200 to +500 degrees Celsius, and readings are clearly shown on an optimized LCD screen. With its IP65 rating, the sensor is fully protected in damp, poorly ventilated areas like basements or utility rooms. Milesight smart current transformers let you monitor electrical current remotely and without any complicated wiring. The best part: you just clamp the sensor around a wire, no need to shut down the system. The sensor is self-powered by the circuit it's monitoring, and it sends data wirelessly through LoRaWAN. You can see a typical use case in the image: the CT sensor clamped on the wire powering a boiler's circulating pump. It tells you whether the pump is running, reports current values as often as every second, and helps spot abnormal behavior early. An optional external temperature sensor can also be added to monitor for wire overheating. In the next firmware update, you'll be able to enter voltage and power factor in the toolbox to get estimated energy consumption. And the optimized version in the fourth quarter will support lower startup currents and offer longer standby time after power is cut off, enough to handle low or even zero current overnight. Meet your specific water detection needs with our robust LoRaWAN sensor portfolio. The lineup includes spot, zone, and customizable membrane sensors, all built with an IP67 rating to withstand demanding conditions. Now for the third and final pillar, unified management. This is where we bring all those smart devices and their functions together onto a single integrated platform. And that connectivity relies on two key components: the right gateway and a powerful software platform. When building up a HVAC control system, it's essential to consider the type of the space. Milesight understands that one size doesn't fit all, so our HVAC control solutions cater to small to mid-size buildings. This adaptability ensures a system that perfectly fits each building's specific environment, wireless or hybrid building environments. As you know, our standard LoRaWAN gateways, like the UG56, UG65, and UG67, are perfect for retrofits where you're setting up a purely wireless network. But what if your building also has some existing wired devices? Maybe a few Modbus power meters or some water valves. In those cases, you'd typically add our UC100 or UC300 controllers to the setup. Now, that approach is technically feasible, and it can be very cost-effective if you only have a handful of wired points. But if you have a lot of distributed wiring, that's where this solution can start to show its limitations. You often end up with a fragmented system and complicated device-by-device configuration. That's where the EG71 really stands out. In mixed wired and wireless environments, especially there are a lot of wires, it delivers seamless third-party integration. It comes with built-in unified decoding for multi-vendor wired devices, and all configuration can be handled centrally from a single EG71. No extra hardware, no complicated setup. So, the choice really depends on your specific wiring needs. For hybrid wireless and with many wired devices, the EG71 is a great value. Now, if you don't have in-house software expertise, but still need a quick way to visualize data and manage devices, I'd recommend starting with Milesight Development Platform and Beaver IoT. These platforms allow fast, low-code integration with Milesight hardware. Beaver IoT is especially solution-friendly, while Milesight Development Platform offers central management, auto-provisioning, and remote access for all Milesight devices. And for those planning to integrate with third-party BMS systems, our UG gateways already support major platforms like Tritium via Niagara Driver, J2 Innovations Fin, and Delta Controls IntelliWeb over BACnet. This compatibility list is continuously growing, and EG71 will also be included after its official release. Now, let's take a closer look at our hardware gateways. What's important to see here is that all our gateways, both the standard models and our upcoming EG71, share some powerful core features. They all offer multiple backhaul options for connectivity, such as Ethernet, Wi-Fi, and 4G cellular, and they come with built-in tools like Docker, Python SDK, and Node-RED for customization and secondary development. A key feature for integration is our Niagara driver. Now, our initial integration was basic. You'd add devices on the gateway, map them as BACnet objects, and then push that data into the Niagara platform via BACnet IP. It worked, but it required you to manage both systems. To make this much simpler, we've developed a dedicated driver that installs directly on the Niagara system. This allows you to create, manage, and communicate with LoRaWAN devices entirely from within Niagara, significantly reducing complexity. So those are the shared features. Now, let's look at the main differences. The standard LoRaWAN gateways have a simplified design with no wired I/O ports, making them ideal for purely wireless projects. The EG71, however, is built for hybrid environments. It comes loaded with a wide array of wired interfaces: RS485, KNX-TP1, M-Bus, universal input-output, digital and analog ports, and dual Ethernet ports. This leads to a major difference in protocol support. While our standard gateways act as a BACnet server, the EG71 can function as both a BACnet client and server. In simple terms, BACnet is the common language that allows different building systems to talk to each other. BACnet client and server enables the EG71 to actively go out on the network, discover other BACnet devices, read their data, and send them commands, enabling true two-way integration. By the way, we are planning to get BTL certification for the EG71 in early 2026. One final important note: our standard gateways are very flexible and can work with either an embedded network server or a cloud-based one. The EG71 only uses its embedded server. So, when working with our Milesight development platform, the standard gateways can handle both device management and sensors data streaming, while the EG71 uses MDP only for device management. This table here really summarizes the key strengths of our different hardware and software combinations. Now, beyond the difference in how gateways work with MDP that we just discussed, there's another interesting point for customers using third-party wired sensors. If you go the route of using a UC100 or UC300 controller with a standard UG gateway to connect to Beaver IoT, the integration and configuration process is a bit different compared to using the EG71 gateway directly. The EG71 simplifies things significantly. If this is a scenario you're dealing with, we should definitely talk more after the webinar. Now let's quickly break down these two platforms. First, the Milesight development platform. Think of MDP primarily as an integration media to accelerate your application development and project deployment. It provides webhooks and open APIs for connecting with third-party IoT applications. Currently, MDP is available as a cloud-based subscription service. For those of you who need an on-premises, free-to-use version, we are targeting a release for that in the first quarter of next year. You can check the link on the slide to see all the Milesight models currently supported by MDP. Secondly, we have the Beaver IoT platform. This is an open-source, low-code platform designed for system integrators and service providers to build their own IoT applications. It comes with all the basic modules you'd need: widgets, workflows, dashboards, and integration configuration. It also uses open APIs to connect with external services. For example, we have customers who've integrated weather APIs for smart irrigation solutions. One important note for Beaver IoT: if you want to connect non-Milesight LoRaWAN devices through either a standard UG gateway or the EG71, they must comply with Milesight-defined codec standards. All the details on that are available in the GitHub link provided. Let me give you a quick look at how the WT101 smart thermostat is making a real difference across different buildings in Europe. In an Italian middle school, they installed WT101 thermostatic valves in classrooms and common areas, along with a gateway in the technical room. The result? Precise temperature control throughout the building, less construction work, and easy integration with their existing BMS system via BACnet. Over in Poland, a Warsaw hotel partnered with Milesight to bring smart climate control to guest rooms. With WT101 radiators and a UG67 gateway, feeding real-time data into a third-party management platform, the hotel can now dynamically adjust heating for comfort and energy savings, and they even supported a child lock feature for extra safety in rooms. Finally, in Croatia, a hospital completely overhauled its HVAC with a wireless LoRaWAN setup. 114 WT101 thermostats, UG67 gateways, and the Milesight development platform with built-in LNS. Onboarding was fast, and using Beaver IoT, the staff built a local dashboard without extra integration. The system is fully scalable and shows just how easy it is to manage complex buildings with smart wireless controls. Across schools, hotels, and hospitals, the WT101 proves that simple wireless thermostatic control can improve comfort, save energy, and make management effortless. Next, let's take a look at how a smart HVAC retrofit transformed the guest experience at Hostel del Arroyito, a corporate hotel in Cordoba, Argentina. Something about the hotel. Originally an old estancia, the property was repurposed as a hotel in 1971. It features 16 single-level rooms, housed in a converted low-rise structure. The estate offers generous space for both guest accommodations and recreational facilities, all on a single ground floor. Before the retrofit, the facility used a centralized HVAC system powered by a rooftop unit that delivered heated or cooled air into a main duct. Each guest room received air through a modulating valve, but all controls were fully centralized. Temperature sensors in each room were hardwired to a controller, and all set points had to be adjusted manually using just 2 wall-mounted control panels at the front desk. This setup presented several key limitations. No individual temperature control for guests. Room settings had to be manually configured by reception staff. Each controller could only handle 8 rooms, requiring 2 interconnected units. No real-time visibility into room conditions. Generalized settings across all rooms led to inefficient energy use. What the client needed was clear: independent temperature control for each room, remote monitoring and management from reception. Better comfort for guests and more efficient energy use, all without replacing the HVAC system or adding new wiring. To meet all of these requirements, Duolink deployed a smart, wireless retrofit solution using Milesight LoRaWAN devices, including the WT201 smart thermostat, UC300 controller, and UG65 gateway, all without replacing the existing HVAC system. Here's how it works. 16 smart thermostats were installed, one in each guest room, giving guests real-time room monitoring and personalized temperature control. An additional smart thermostat was installed at the reception desk, providing a general temperature reading for the common area. The WT201 transmits environmental data over the LoRaWAN network to a central management system, which calculates the required valve opening percentage, then sends that command to the corresponding UC300, enabling precise and dynamic airflow control. Next, 16 UC300 controllers were installed, one per room, to control the existing modulating air valves according to the command from the management system. These valves receive analog signals, typically 0 to 10 volts or 4 to 20 milliamps, allowing for precise variable airflow rather than basic on and off control. This ensures smoother temperature regulation and better energy efficiency. Since all the rooms and facilities are located on a single ground floor structure, just one UG65 gateway is enough to provide long-range, stable wireless coverage for the entire area. All devices operate over a LoRaWAN wireless network, avoiding the need for new wiring or infrastructure changes. Hotel staff monitor the full system from a dedicated PC interface at reception, with access to each room's status in real time. As you can see from the before and after installation photos, this retrofit not only enabled in-room temperature control, greatly enhancing the guest experience, but also delivered remote monitoring, energy savings, and easier system scalability, all with minimal disruption to hotel operations. In a market where differentiation and optimization of resources are key to success in tourist apartment businesses, having environmental monitoring tools has become a competitive advantage. The ability to monitor environmental conditions in real time not only improves the guest experience, but also optimizes energy consumption and reduces operating costs. Our client, Nex Mahana, launched a project to manage tourist apartments in Spain, where implementing a scalable, flexible, and affordable technological solution proved challenging. One of the main issues was the lack of an efficient system for remotely controlling the air conditioning. Without real-time data on guest behavior and proper monitoring of heating and cooling usage, it was difficult to ensure comfort, prevent unnecessary energy consumption, and avoid misuse. With this starting point, Nex Machina sought to implement a solution that would allow it to intelligently monitor and manage the environmental conditions of each apartment, optimizing energy consumption and improving the guest experience. The Milesight WT301 Smart Fan Coil Thermostat is a state-of-the-art thermostat for air conditioning systems with fan coils. This solution was implemented in 90 tourist apartments to optimize heating and air conditioning control with programmable schedules. The WT301 with a touch screen has now been upgraded to the WT303, which features an e-ink display and physical buttons. Here's another great example from a well-known health resort in Croatia. They launched a large-scale energy management and digitalization project to improve efficiency, guest comfort, and sustainability. The project covered 7 buildings with very different functions. That meant a big challenge around multi-building integration, reliable connectivity, and smart logic programming. This is where Milesight's LoRaWAN-based solutions came in. We deployed indoor air quality and temperature sensors, all connected through our UG67 gateway. The system gives the resort real-time visibility of energy and water usage, indoor comfort levels, and environmental performance. On top of that, we added real-time leak detection to prevent costly water damage, and smart HVAC control that automatically adjusts when windows are open or closed, saving energy while keeping guests comfortable. I'd like to talk a little bit more about the HVAC control. For the fan coil units from Daikin, the WT30X doesn't quite meet all its wired terminals. What then? By reviewing the Daikin FXLQ P-Series FCU wiring, our partner implemented the UC300 as a practical alternative solution for remote on and off control. The UC300 controller can be easily powered via 1.5 to 24 volts DC through the terminal block. Since fan speed control is not required, the two built-in dry contact digital outputs enable smart control of FCU 4-pipe, 2-wire, and 2-pipe 3-wire on and off valves. Compared to installing an FCU thermostat, using the controller is a much more cost-effective solution, but also a much more complicated installation. The results have been clear: better air quality, smarter use of energy, fewer risks from leaks, and centralized monitoring that makes operations much easier. For more Milesight insights, please keep following us on our social media. Thank you all for your attendance today, and see you next time.